The day I got my Nikon P900 in the mail, I went and picked it up and opened it up, and I then pulled out my flight tracker just to see what there might be in the sky to take a picture of. I couldn't figure out what them balloons were doing up there, so I hurried up and grabbed a couple pictures of them. Didn't know anything about the camera, just had enough battery power to get them two pictures. Started doing some research and found out they're called Google Loon Balloons. They're used to go from Utah. They go anywhere in the world in North and South America, and they use them for Wi-Fi. One will talk to the other one and broadcast Wi-Fi down to the ground, or however it works, but they can have 3-4 of them in a location. So if you get Flight Tracker 24, you could probably spot them. I'll show you a picture right coming up now where they've been, and they move only about 2-3 miles an hour, sometimes 30. They don't travel very far, so that discredits the Coriolis effect. They stay in the sky. They can stay in the sky for quite some time in one location. They do wander back and forth in the nighttime if their computer goes dead, where there's no solar light coming in to charge their batteries. The first picture I started out with shows they have an air bladder inside, and use electric fan to put air into them so they'll sink. And then or take the air out and makes them rise, and they control which direction they go by the breeze that they can pick up. I've enjoyed taking pictures of the moon. I started out with a heavy-duty pair of binoculars on a good stand and my iPhone taking pictures, so some of them might be one of them or so. That was very difficult because I couldn't get it on the right and keep things level. But you can see that I've taken multiple pictures. But one thing I did find out is the sun lights up the moon. The moon is not self-lighting. And coming up will be some pictures. The sun will be bright, and I faked out my camera by shining a light down it, and it took the picture of the back side of the moon. And I got quite a few of them like that. So I know the moon is not self-lit. I don't know how it reflects the sunlight, but there's people that say the moon has its own light, and I would disagree with them 100%. And you can see here in a minute, I also have a Nikon D3200 with a 55-300 zoom lens. You can see these next few pictures coming up. We're out in the mountains, and I got a picture of the moon coming up, and then to follow it, I have a picture here that shows the backside of the moon that's not lit, and then the sun coming up on the mountain. And you can actually see about where they both come up on the same position on the mountain. Here's the sun coming up, and I got a few shots of that. And then back to some more of them pictures I said I had with the moon lit by the sun. So I've got a lot of pictures that I've done like that. There's some people looking to see the oscillation of the moon. I hope they get a chance to view these movies that I had put up on the moon, because I left the dates on the pictures so they can look back and maybe see some of it. But they say the moon oscillates back and forth, kind of like a roll. And so that's what I posted quite a few of these up for. This is a United States floodplain map. You can notice the bottom right-hand side has elevations across United States. That shows you there's no elevational change over less than 1,800 feet of elevational change from the headwaters of the Mississippi and Canadian border down to the Gulf of Mexico to the end of the Mississippi. Flow of the Mississippi at the headwaters is 1.5 miles an hour. Through the center it's 2 miles an hour, and down at the bottom it's flowing at 3 miles an hour. On this elevation of 1475 at the headwaters of the Mississippi, and it goes lower down to the Gulf of Mexico. These are short little clips on these floodplain maps. One is at 345 meters, another at 300 meters. What it's showing is the line that would be cut off, or area at that elevation. But a flood moves in different ways. You can get a lot of rain in one state, and it'll move through another state and flood that other state without them having any rain. What I'm trying to show here is across the United States, it's roughly 1,800 miles across there, and the elevation is pretty much the same. So how does that work if you calculate the elevational difference in the Earth curve calculator, it comes up with 239 plus miles of elevational difference. Do you see that across the United States with the elevations I showed you? So you can't have it both ways. It's the elevation. Otherwise, the Mississippi would cut a trench through the United States like the Grand Canyon and deeper. The sun actually passes the moon during the day, and when that event takes place, it might take you a day or two to see the moon again because it's always so close and so bright. The sun is so bright you wouldn't be able to see the moon. Or look in the evening night sky when the sun just goes down, you might find it then.
The moon has something we call phases, which means that it appears to change shape a little bit every night. To understand why this happens, we need to talk a little bit about the way the Earth and the moon move together in space. The moon orbits around the Earth, much like the Earth orbits around the sun. However, while the Earth takes about 365 days to travel once around the sun, 1 year, the moon completes its orbit around the Earth in only 29.5 days, or about 1 month.
Would still be able to see all sides of the moon, right? What if the moon both rotated and revolved? How about like this? Look carefully, and you'll see that, yes, we still get to have a 360-degree view of the moon. No hidden sides. But what if the moon rotated just as fast as it revolved? Like this. Ooh, check this out.
I want to make a comment on the first video picture of the moon there. She is wrong. It's a 27-day cycle, but it comes around every day or every night. You can look up and see the moon in the sky. It does not take 27 days to circle once. And the comment else I want to make on both them clips is they depict the moon going counterclockwise. It actually goes the opposite direction of the display in here. It starts in the east and goes to the west. If you look, you can see it every day. I want you guys to take and go and observe the moon. Get out there and see it every day, every night. Try and get an app on your phone to tell you where it is, to find it in the sky. Then you'll see what I'm talking about. I was talking with a friend and I had to go up there many times and point out where the moon is and say, there it is in the sky. Now which way is it going to move? Go out there tonight after supper and take a look. I encourage you when you fly to do a time-lapse video out your window. If you do it for an hour, you're going to have quite a few miles of flight because you're traveling about 450, 500 miles an hour. And then you'll see really how flat the Earth is. Check out on YouTube infrared camera work out airline windows. That's kind of interesting how far they can really see with an infrared camera.